In Chapter 7, we will start the process of statistical inference, that is, taking information from a sample to make estimates about a population. In this first short lecture, we will discuss sampling. Let's start with a few definitions. An element is the entity in which data are collected, and a population is a collection of all the elements of interest. And a sample is a subset of that population. In business, it is frequently not possible to understand all of the elements, the data, from a population. In order to make decisions, we most often can only get data from a sample. Using information from the sample, though, we can infer or make estimates about the same information for the population. And with good sampling methods, we can make good estimates of population characteristics. There are two cases to consider, a finite population and an infinite population. For a finite population, we need to be sure to select a simple random sample to ensure that we have the same probability for any sample of size n. The best way to ensure that a sample is random is to sample with replacement. But sometimes it's only possible to sample without replacement. Ideally, we would use random number generation to ensure a random sample. But as we learned earlier, other probability sampling methods are possible. We will discuss those in more detail at the end of this chapter. Let's use an example that could be familiar. The director of admissions at a university had to get information quickly about 900 applications. He or she could select a simple random sample of 30. The most effective would be using a random number approach, but more likely he or she might have used something like systematic sampling, for example, choosing every 10th or 20th application from a pile. When sampling from an infinite population, it is not possible to use the random number assignment. Infinite populations are more common in business, and we need to know how to select random samples. What is most important in the case of an infinite population is to ensure that each element is selected independently and that we're sure that the sampled items come from the population of interest.